adding the capacitor, we will be able to reduce the power loss. So making additional transmission capability that which means your ability to take more power from the line, that you are able to do that. Power loss, it is literally reducing, that you are able to see it. Reactive power supplied by capacitors, hence no building is required extra. Reactive power supplied by utility, you don't need to go because we are internally generating it, right? That's the advantage. Okay, so so basically when you add this, your apparent power requirement also will come down, right? This also will come down, otherwise your apparent power also will be bigger. So these are all the advantages, right? You see, one, you could see this electricity bill, you can reduce. Reduction in kVA demand also will come down, right? And reduction in kVA also will come down. Total apparent power also will come down. Then now the moment it reduces, you know that line current also will come down. Because of that line current, another advantage, maybe your switchgear rating may come down. Line losses, cable losses may come down. Then sometimes even that will act as a voltage regulation also. Your bus voltage also can be regulated because of this. That also is possible. But the case what we have taken, maybe that we need to adjust slightly, but that is also possible. Okay, and your transformer loading also, of course, it will come down, right? This is all the major benefit with respect to the reactive power. So again, that's what again it is mentioned here. Okay, so let me look at this. This is the step process that I have given. One is reactive, like how to calculate that one. Second one is like this is what, when you have a different types of loads, you need to figure it out where you have to put the capacitor bank, at which location you have to put the capacitor bank, that you need to look at. One is global for complete installation, that is what we have done it now, by sectors or by individual. Let's see that what it is. Okay, in the next slide we'll see it. Then this is actually sometimes you can give the capacitor as a fixed one, or sometimes you can give the capacitor with the different steps, so that will be automatic. There is something called dynamic, that we'll see it. Okay, so sometimes you may have to add a filter along with, if there is a harmonics and etc. That is a last step that we will look at, right? You see, I will tell you that part actually. Even when the transformer is not connected to any loads, at the time also it will consume some reactive power, because transformer also the core needs to be magnetized, right, for that percentage. So for that, typically they will add one small capacitor in that also. So that is typically 2% of the transformer kVA rating. They will consider it. Like you can go with that. Okay, that you can consider it. But if your transformer, that is only if you are, some people due to the redundancy purpose, they will keep the transformer idle and it will be like no load. It will be a like standby transformer. So for that, you need to have this capacitors, because it will consume a lot of reactive power, right? That is one thing. Second, so this is the formula that I have applied actually. So this is the point that I wanted to add it. See, after the transformer, global compensation, right? You see compensation by sectors. You see that CC, central compensation. That means immediately after the transformer, you can give as a central compensation. Then group of compensation. This is group of compensation. And individual compensation. This is an individual compensation. There you can categorize into three types.